right. And Keely said we don't have to find common denominators when we add. We just multiply. We multiply our numerator times our numerator and our denominator times our denominator. But what's one important thing we have to make sure we do? Simplify. Okay? And I had a couple of you that were absent, so I thought today would just be a good day to refresh our minds coming back from break. So we're going to do a quick review for those of you that were here and a quick lesson for those of you that were not on how to multiply fractions. Okay? Today we're going to keep it simple. We're just going to do a fraction by a fraction. At the bottom of the little review that I gave you today, I gave you a whole number times a fraction. We'll touch on that tomorrow. But let's see how this goes. So if I start with a simple fraction that looks like 2/3 times 1/6. Okay? Just as Keely told us, I don't have to find common denominators, right? All I have to do is do what, Landon? Let's multiply first, then we'll think about reducing. Can you use better terms? What do we call the top and the bottom? What do we call those? I multiply my numerators and then I multiply my denominators. Caleb, are you with me, buddy? Okay. My numerators, so I take 2 times 1, which gives me 2. And I take 3 times 6, which gives me 18. What's wrong with 2 over 18 as my answer, Chelsea? It's not simplified. How would I reduce this? How would I simplify this, Gabe? 2 over 18, how could I simplify that? Absolutely. I could divide both my numerator and my denominator by 2. What's 2 divided by 2? 18 divided by 2? 9. Okay. Just a quick pointer. You all know that if you have 1 as your numerator, that fraction is as low as it's going to go, right? Did you all know that? Yeah. Okay. If you have 1 as a numerator, that fraction is as low as it's going to go. If you have a fraction that has consecutive numbers, one over top of the other, consecutive means like 6, 7, and 8. Those would be consecutive order. Numbers, they're in order. 1, 2, 3, those are consecutive. They count in order. Okay? So consecutive numbers are numbers that count in order. Okay, so would 7, 9, 12 be consecutive? No, they would not. But would 7, 8, and 9? Yes. Okay, so anytime I have a consecutive set of numbers like 7 over 8, it's always simplified. 11 over 12, 142 over 143, always in simplest form when they're consecutive numbers. Does that make sense? Okay. Let's look at another quick example, and then I will let you get started at your homework. Okay, so if I have 6 over 7 times okay, let's look at these two numbers. I chose some larger fractions this time because I also taught you a strategy of simplifying before we multiply. Does anybody think they can talk us through that? How do I reduce these fractions before I multiply, Hayden? You're right as far as this individual fraction and this individual fraction, neither one of those, but I showed you something where we can look to see if we can simplify before we multiply, instead of multiplying and then simplifying my final fraction. Is it coming back? Okay. It's the start of the butterfly effect. We cross-reduce, if I had a marker. It's called cross-reducing. I circle this set of numbers, and I circle the diagonals this way. I can cross-reduce. I can reduce diagonally, and that will make my number smaller. Okay? So, when I look at the number pairs that I have circled, I have 6 and I have 15. Is there any number that goes into both 6 and 15? 3. So I can divide 6 by 3 and get 2. And I can divide 15 by 3 and get 5. Okay? Is there anything that I can divide 7 and 14? I can divide by 7. I cannot divide by 2 because 7 is prime. But I think you were thinking 7 times 2 is 14. Okay? 7 divided by 7 is? And 14 divided by 7 is? 2. So now my new fractions after I cross-reduced are 2 over 1. I'm just bringing these numbers down here so I can see them a little bit easier. And 2 over 5. Now I have smaller numbers. All I have to do is multiply my numerators. 2 times 2 is? 1 times 5 is? 5. Okay? Let's go back to this original problem of 14 over 15. And 6 over 7. And let's do the math just to make sure I didn't lie to you. I would normally lie to you on purpose, but I might have. What?
Whenever you got the fractions on the side and you brought them down, the first fraction numerator.
It's okay. That's okay. I care about my end result. And if that would have happened, I would have just had to change it to a mixed number, which is what's going to happen tomorrow where we do whole numbers. Okay, 6 times 14. Anybody got it? What's 6 times 14? 84. His math is correct. 7 times 15. 15, 30, 45, 60, 75, 90, 105. He's correct too. How many of you can easily reduce that one? It's kind of ugly, right? She right? You agree? You want to divide it by 7? And what is 84 divided by 7? What is 105 divided by 7? Can I reduce 12 over 15? Pretty sure I can divide them both by 3. What is 12 divided by 3? What is 15 divided by 3? Notice how this answer is the same. Okay, so, as I've told you many times, I don't care how you get to the answer. I don't care if you reduce before you multiply. I don't care if you multiply and then reduce. Do whichever one is easiest for you. Does anybody want to see another quick example of either type? Okay, multiply straight across the top, multiply straight across the bottom, and reduce. Okay, if that crisscross method confuses you, don't use it. Okay, if it's easier for you to think, I just need to multiply my numerators, get an answer, multiply my denominators, get an answer, and then simplify that, do it that way.